Consider a pure capacitor. Okay, it is connected to some source E is equal to E naught sine omega t. Now the capacitor has to charge, correct? So let's say a charge of Q coulombs passes through the capacitor, meaning it charges the capacitor. Okay, now if Q coulombs is charging the capacitor, some time t has to happen, correct? So what we consider is a very small amount of charge dq is going in an instant, that is time dt. Okay, all right. So now by capacitance formula, what we have? So we have C is equal to Q by V, or you have Q is equal to C into V, correct? Now in this case, the voltage source is nothing but E, correct? So we have E is equal to E naught sine omega t. So we have Q is equal to CE, right? Now a small charge we are considering. So we have dq is equal to CE into dt. Now what was E? Substitute that here. So we'll have Q is equal to CE naught sine omega t dt. Okay. Now current was given by what? The rate of change of charges, correct? So here we have Q, correct? So you differentiate that to get the current. So we have dq by dt is equal to d by dt of CE naught sine omega t dt. dq by dt is equal to d by dt of CE naught sine omega t. So basically you have to differentiate this. So you'll have I is equal to CE naught omega cos omega t. Okay. Now cos omega t can also be written as sine of omega t plus pi by 2. Okay. So go back to trigonometry, you'll understand. So you'll have cos of omega t as sine of omega t plus pi by 2. Okay. So we rewrite the RHS equation as E naught divided by 1 by omega c. Okay, because the new denominator of the denominator goes to numerator. So we have I is equal to E naught by 1 by omega c into sine of omega t plus pi by 2. See here 1 by omega c has the same unit, that of resistance. Okay, so we call that as capacitive reactance. Okay, or XC will be 1 by omega c. Alright, now you get I is equal to I naught into sine of omega t plus pi by 2. Okay, the EMF was E is equal to E naught sine omega t, and I is I naught sine omega t plus pi by 2, correct? So what we have here is current leads by pi by 2, or EMF lags behind current by pi by 2. Okay. Now, sinusoid, the graphical way of representing would be this. See, this is the EMF and this is the current. Okay, so as you can see, current is leading the EMF by pi by 2. Or if we have to represent by the phasor diagram, so if this is E, see this is omega t, this will be I. So from omega t, you're again pi by 2 you have to go. Okay, so this is the phasor diagram.